You are in dropper batch, right? Like you gave the paper of class 12. Okay, no problem. So basically, today we are going to have a trial. You are going to have a trial class with me, and I'm going to start from very basic. The first chapter of class 11, which is some basic concepts of chemistry, and we also call it mole concept. So I want to ask you some questions like, how's your physical chemistry of class 11, like the first chapter of class 11? How's it? Because in physical chemistry, whenever you are going to study other physical chemistry, there will be terms like mole, molarity. So these chapters indirectly connected with other chapters. So can you tell me how's your this chapter? Some basic concepts of chemistry. How's it? Why descent? Descent in your term means like, what do you think? You are good at this or okay, you know this term. So I'm gonna ask some questions, simple questions. Okay, so that I'll be able to understand where you actually understand in this chapters. So let's start with a question, and that is very simple. I'm gonna ask you 4.9 gram of H2SO4 present in 500 centimeter cube solution. Calculate molarity. And normality as well. I think you can do this. So first let me know the answer. I gave you a very basic question, so you can do this easily. Zero point 0.1 molar. Okay, go for normality. I'll check it. Very good. The answer is correct for molarity. If you have studied the solution chapter carefully, you can do this both questions, both part molarity and normality. Any answer? This is quite good. And for normality, you know that it will be number of gram equivalent upon volume of solution in liter. But number of gram equivalent is not given directly. So number of gram equivalent has a formula, as you already know. that is given mass upon equivalent mass. Given mass, you can see that is 4.9, and equivalent mass, we have to check equivalent mass or weight of what? H2SO4. So this will be equal to molar mass of H2SO4 upon X, that is N factor. So molar mass of H2SO4, you know that that is 98, and X, that is N factor or valence factor. It is acid, so it will give 2H plus. That's why the value of X here will be 2, and you will get 49, and hence the value will be 0.1 gram equivalent. Now you can put this 0.1 and then 500 centimeter cube. You have to convert this into liter, right? If you are going to convert this into liter, you will get 1 by 2. That means 0.1 divided by 1 by 2. So it will be 0.2, I think. Let me check the calculation again. First, we have to calculate the number of gram equivalent, given mass 4.9 upon equivalent mass, which is 49. So you can see this will be cancelled and 10 will be here. So it becomes 1 by 10, which means 0.1 gram equivalent. 0.1 gram equivalent divided by, you can either do it like this, 0.1 divided by 0.5, and hence the answer will be 0.2. Okay, no problem. So you have to be careful while applying the formula. You need to be focused. Okay, there is some questions. If I'm going to ask you, calculate equivalent weight or equivalent mass, you can call it, of the first one is H3PO4. This is a very good question. H3PO3 and H3PO. There is a questions has been asked on this compounds, which is very important. So I think you can do this. Equivalent weight, you already know that comes under normality. You know the formula of equivalent mass, right? Okay. So let me just check it. Can you tell me the molar mass? You know that the formula of equivalent mass or equivalent weight is equal to molar mass upon X. So can you tell me the molar mass of H3PO4 that you have calculated? Yeah, molar mass is quite easy, right? For H3PO4, it is 99. What will be the value of X? That is N factor. You have calculated 3. So it will be 33. Very good. Very good. And for the second one, let me know the molar mass directly. Molar mass. What is the molar mass of H3PO3? Which is very easy to calculate. 331 plus 3 into 16, that is 48. 48 plus 31 plus this, so 34. So it will be 82, right? Yes or no? What is the molar mass? Yeah, 84. What is the N factor of this H3PO3 that you have taken? 3 as well. Okay, if you have taken 3 and then you solve it like this, right? Okay, we will discuss about this. Now tell me the equivalent mass of the last one. What is the molar mass of the last one? Is 3PO2. 32, 31, that makes 63 and 66, right? Oh, wait a minute. 32 plus 31, that makes 33. Sorry, 63 plus 66, it will be now. Like 3 hydrogen is there, phosphorus has 31, and 1 oxygen has 16, 2 oxygen is there. So it makes 32. Plus you can see 31 plus 3, that makes it 34, and it will be 66, right? Please do cross check it. Will it be 69 or 66? Okay. So it will be 66. What is the value of X that you have taken? 3. Actually, this is what I needed to tell you. And unfortunately, this is correct and this is not correct. So you know how we calculate equivalent mass. Equivalent mass is equal to molar mass upon X, which is n factor. And you know, molar mass, you can easily calculate it of any compound if you know the atomic mass. And generally in exams, atomic mass is given. So we don't need to worry about the molar mass. We need to only worry about the value of X, which is n factor or valence factor. Why we need to worry about this? Because with the change in compound, the value of X changes. And you know what? I divided this, actually the n factor says the change in oxidation state. If when we will study redox reaction, it is about change in oxidation state. Change in oxidation state. Change in oxidation state. Okay, just like for an example, if there is a reaction C2O4 minus 2 that reacts with something and it changes into CO2 and something. So what will be the n factor for this carbon? So if you are going to calculate the oxidation state of this carbon, it will be basically just wait a minute. Let me change this because it will be a little bit tough to understand right now. If we have this MnO4 minus, it will be converted. Let's say this is a reaction Mn plus 7. So if you are going to calculate the oxidation state, this will be plus 7 and there is plus 2. So what is the change in oxidation state? You can see plus 7 to plus 2. So total change is 5. So for this reaction, the n factor of this manganese is equal to 5. So, but in here, the value of X is quite easy to calculate. If it is an acid, if it is a base, and if it is a salt. So how we are going to define? So it's very easy. What you need to focus is if it is acid, just see how many number of H plus it gives. How many number of H plus it gives? That is the value of X. Like if I'm going to give you HCl, you know, 1 hydrogen is there, so it will give only 1 H plus. That's why the value of X for this HCl is 1. If there is H2SO4, you know this this has 2 hydrogen and it will give you 2 H plus, so it will have value X is equal to 2. In the same way, we go for base, X is equal to number of OH minus, number of OH minus. Like if you have NaOH, you know there is only 1 OH minus given by this sodium hydroxide. So the value of X is equal to 1. And in the same way, MgOH whole twice, it will give you 2 OH minus. So the value of X is equal to 2. What is for salt? Salt, you know that it comes from neutralization reaction. If you have this NaCl, which is a salt, and the value of X here for salt is either you are going to take positive charge, like total positive charge. Either you are going to take total positive charge or either you are going to take total negative charge. Since this salt comes from neutralization reaction, so the total charge will be basically the total positive charge will be equal to total negative charge. That gives you neutral. Like if you are going to dissociate it, you can see there is only +1 and there is only -1. So either you can take +1 or -1, but don't take the sign. You are going to take it with mod. So value of n factor for this NaCl is 1. If you have CaCO3, you are going to dissociate it, and you know that calcium is from second group, so it goes in +2 oxidation state and CO3 -2. So you can see that both the charge are equal, x is equal to 2. In the same way, MgCl2 is there, and if you are going to dissociate it, you will be getting Mg +2 Cl minus. Either you are going to take positive charge or either you are going to take negative charge. It will be similar. You can see if you are going to take positive charge, it will be 2. If you are going to take negative charge, it will be 2. Why? One Cl has one minus charge, so 2 Cl have total charge of -2. But we need to take only the number magnitude, not the sign. So why I explained this, it's very important. This concept is quite important, and I think you are writing it right. Okay. Let me know, then I will change the slide and come to the phosphoric acid, like phosphorus acid H3PO4 and H3PO2 and H3PO3. Let me know. Now we are going to talk about this, what we say. We are going to talk about H3PO4. You told me that the value of X is equal to 3 here. That means it gives you 3H plus. Very good. And then it is H3PO3. You told me X is equal to 3. That means it also gives you 3H plus. And in the same way, H3PO2, you told me X is equal to 3, which means 3H plus given by this. Out of these three, this is quite good. Basically, this is correct. Actually, you saw 3 hydrogen is there. So simply it will give 3H plus. In the same way, you applied here and here, which is wrong. Which is wrong. Basically, the correct value of X for this reaction is 2. That means it gives you 2H plus, and here you can see the correct value of X is equal to 1, and it gives you 1H plus. That confirms you if the value of X is 2, that gives you 2H plus. If the value of X is equal to 1, that gives you 1H plus. And if the value of X is equal to 3, correct, that gives you 3H plus. So how you are going to decide whether which acid or which compound is gives you how many number of H plus, OH minus, or the positive or negative charge? So it's very simple. If you have studied P block in class 12, you know the structure of this H3PO4 is like this. No, the structure is like this. Yeah. For H3PO3, the structure will be like this. And for H3PO2, do you remember it now? Furqan? So I still okay. So basically, when we will, can you draw the structure of H2SO4? Yes or no? Okay. So just draw it and match it with me. It will be like this. Yes or no? So basically, H3PO4 is oxo acids of phosphorus or oxy acids of phosphorus. In oxy acids, at least there will be a double bond with oxygen and one OH bond will be there. At least one OH bond will be there. So how I draw this structure, you know, P double bond O first. Then I looked at oxygen and hydrogen, 3 hydrogen, 3 oxygen is there. and phosphorus can make maximum of 5 bonds. So I added OH, OH, OH. Now, for the second one, P double bond O is necessary, compulsory, and one OH bond is also compulsory. Now we have two hydrogen left. Let me draw it again for you. Just focus it. If you have H3PO4, so this is your oxy acids of phosphorus. Oxy acids of oxy acid of phosphorus. Oxy acid of phosphorus. What is oxy acid? So oxy acid is the compound in which non-metal oxygen and hydrogen is there. Any compound in which non-metal oxygen hydrogen is there, that is your oxy acids, and whatever is the non-metal, that is the oxy acids of that non-metal. Like if I'm going to write H2SO4, you can see non-metal, oxygen, hydrogen. So this is oxy acids of sulfur. If I'm going to write HClO4, non-metal, oxygen, hydrogen, oxy acids of chlorine. Are you getting my point? Okay. Now come to the point. For to be an oxy acids, there should be, with non-metal, there will be a double bond and a single bond, which is OH. Are you getting my point? To be an oxy acid, double bond with oxygen and single bond with OH. Single bond with OH. And do you know maximum bond that phosphorus can make is 5? This is pentavalent. Okay. So P, and I will close my eyes and I will write this because this is compulsory, right? Now, how many hydrogen we have left? 2 hydrogen, 2 oxygen. Okay. So I'm going to write it like this. Simple. Do you know, whenever you are going to draw a structure and oxygen is surrounding atom like this, oxygen will make double bond. This is compulsory. There will be exception, not exception actually. There will be situation in which it is not possible, but very less. Whenever oxygen is at surrounding or corner atom, it will make double bond. So if you want to draw an structure like this, like if you want to draw like this will be wrong, because where you are going to draw the hydrogen, and phosphorus only makes 5 bonds. So this is only the possibility that you will get, and hence the structure will be like this. Okay. For H3PO3, I'm going to discuss about H3PO3. The compulsory point is this, yes or no? Tell me. Now, 2 bond already made by phosphorus, 3 bond. You have to make 2 more bond. You cannot draw only oxygen alone because it will make double bond. And if it will make double bond, then it is having 4 bond already. And you have how many hydrogen? 2 hydrogen more left. So what I'm going to do? I'm going to do this, which, and then this. Hydrogen can make 1. And simply in the same way, H3PO2, the compulsory thing I'm going to do is this. And you can see 2 hydrogen is there. 2 hydrogen only we have left. You can see all the phosphorus is making 5 bond, and everything is set. Now, why this H3PO4 gives you 3H plus, gives you 2H plus, gives you 1H plus? This is due to the fact that, you know, there is 3 OH bond. There is 3 OH bond. First reason, very simple reason, 3 OH bond, it will give you 3H plus. 2 OH bond, it will give you 2H plus. 1 OH bond, it will give you 1H plus. Now we are going deep inside the concept. Why this OH? We are considering only the OH to give H plus. It is only because, you know what, oxygen is the second most electronegative element. So it will have delta negative, delta positive. In the same way, delta negative, delta positive, delta negative, delta positive. Since oxygen is second most electronegative element and hydrogen is very, very less electronegative, so the bond becomes polar. This bond becomes polar. And when you are going to dip this in water, which is already polar, In solution chapter, you have studied in solubility that solubility principle, like dissolves like. That means polar solute will be soluble in polar solvent. Are you getting my point? Are you remember this? Have you remembered this? Very good. So you can see all these three bonds are polar, and when you are going to dip in a polar solvent, it is dissolvable, and this bond easily be broken, and it gives you 3H plus. When you are going to talk about this, you can see polarity is there. Polar bond is only two polar bond. The electronegativity difference, basically phosphorus is not that much electronegative. That's why this bond is not that much. This is polar, but not highly polar. It is very, very less polar. So it cannot be broken easily. And hence it will give you 2H plus. It will give you 2H plus. And in the same way, you can see it. This is the only polar bond, highly polar bond. So it will be dissolvable, soluble in water, and it will give you only 1H plus, and the rest will be as it is. And hence the molecule equivalent weight of this, whatever is the molecular weight divided by 1, and for this, you know that whatever is the molecular weight divided by 2, and for this equivalent weight will be equal to whatever is the molecular weight divided by 3. So I think it's clear to you, right? Now let me know when you are done with this. Okay. I'm just actually, this whole concept will be clear when we are going to have the regular class. You will know how to draw the structure, each and every concept you will be getting. So, for getting the actually, you don't need to uh, for all compound like H2SO4, you know that it will give a 2H plus. But if you are going to draw the structure, it will that will be much better. And again, it will consume your time. So we actually did a lot of questions, practice a lot of questions. Like if I'll ask you what is the molecular of weight of H2SO4, you have solved so many times that you will say 98. You will not calculate it, right, Furqan? So this is like the same. We will do a lot of practice. We will do a lot of question that will cover almost all compounds. Okay, so you don't need to like again, if we I will ask question, and if there will be a question in your test raised about H3PO4 and SPO2. So I think when we will study chemical bonding, am I audible? Am I audible? Oh, I know. Yeah. So what I was saying is that just wait a minute. You don't need to draw the structure of every compound. You need to do a lot of practice, and then eventually you will know where to apply and what is the number of n factor and all. Okay. Okay. So I'm gonna give you a question. Let me know if you will be able to solve this question. Will you be able to solve this? Please do it. So it's option C. So what did you do? You calculate the number of moles, right? If you are going to calculate the number of moles, you will get 1 mole here, right? And for this, again, you will get 1 mole. And for this, again, you will get 1 mole. But for this, you will get 4 mole. But we don't decide with moles. We calculate the number of molecules as in question has been asked. Very good, very good. So you know the basics of this, and you know if you are going to calculate the number of molecule, it will be 4 into n, and all other will be 1 into n. So this will have same number of molecules. B A B D C. Whenever you are going to solve by yourself the homework or the questions at home, you need to think also about other options. Like what I told you is that this is correct answer. Very good. So what will be the number of molecules for other three, A, B, D? The number of molecules for other three will be equal, right? Yes or no? Furqan? Yeah. So if you think like this, from one questions, there will be more concept and there will be more practice of yours will be gone. Just wait a minute. Okay, I'm going to give you a question on stoichiometry, which is very easy. Let me see whether you are able to solve it or not. And this is the question. Okay, no problem. You know what? It's very easy. Nothing to worry about. And stoichiometry is all about what we say. It's about unitary method. Are you aware of unitary method? If you are going to spend 50 rupees and you are getting 10 pence, can you tell me how many pence you will get from 30 rupees? If you spend 50 rupees for 10 pence, what will be the number of pen if you are having rupees 30? 6 pence. So what you have done for rupees 1, what will be the value? 10 upon 50. And for rupees 30, what will be the value? 10 by 50 into 30. And you got the value 6 pence, right? Very good. 50 into 10. No, it will be 10 by 50, right? 50 by 10 is, wait a minute, wait a minute. 15 to 10 for me. I mean 15 by 10. No, not 15 by 10. For 1 rupees, you will get 10 by 50 pen. You just did opposite of this. You write the value of money, right? 50 by 10 rupees, right? For 1 pen. Right, Furqan? So it's just like stoichiometry is very simple. You know what? There is CH4 plus O2 that whenever hydrocarbon will be combust, if you are going to combust the hydrocarbon, burn the hydrocarbon, that means you are going to react this with oxygen and you will be getting CO2 plus H2O. That is confirmed. When you are going to burn hydrocarbon, that means carbon and hydrogen, that means you are going to react this with oxygen, you will get carbon dioxide plus water along with heat. This reaction is exothermic reaction. Now you need to balance it. If there are 4 hydrogens, so I'm going to write 2 here. Now 2 hydrogen is there and total oxygen 4 on the right hand side. So I'm going to write 2 on the left hand side. So whenever we are going to solve, or whenever we are going to talk about or solve the question of mole concept, you are going to balance the equation. It is very, very necessary. If you will not balance the equation, you will get wrong answer. Okay. Now see how we are going to read. We are first going to read only in mole terms. Mole terms. You know what is coefficient? You have studied this in class 10 about the coefficient. What is coefficient? In maths, if I'll tell you x2 x cube, what is the coefficient of x cube? That is your 2. If I'm going to ask you what is the coefficient of x, that is 3. So the multiplied number in the variable is called coefficient. And in here chemistry, we talk about a stoichiometric coefficient. We say it as stoichiometric coefficient. That means the number or the constant multiplied in any compound atom molecule, that is your stoichiometric coefficient. Like if I'm going to ask you, what is the stoichiometric coefficient of this H2O? 2 is the stoichiometric coefficient. What is the stoichiometric coefficient of CO2? What is the stoichiometric coefficient of CO2? 1. That's very good. What is the stoichiometric coefficient of O2? That is 2. What is the stoichiometric coefficient of CH4? That is 1. Now, how we are going to write it? This stoichiometric coefficient indirectly represent number of moles. So what I'm going to write, you know that CH4 reacting with O2 to give you CO2 and H2O. Very simple, right? CH4 reacts with oxygen to give you carbon dioxide plus water, right? Can I read this? Now, how we actually read in terms of chemistry when we are going to calculate 1 mole of CH4, this positive, that means reacts with 2 mole of O2 to give this arrow, we can say to give 1 mole of CO2 and 2 mole of water. Simple, yes or no? Very good. It's very simple. Now, what if I'm gonna ask you, if 10 mole of this is given, 10 mole of this CH4 is given, how many O2 or how many moles of O2 is required? How many moles of O2 is required? So you are simply going to apply the unitary method. For 1 mole, you need to react 2 mole. So for 10 mole, you need to give 20 mole of O2. Are you getting my point? Very good. Now, for 1 mole, you are getting 1 mole of CO2. So if 10 mole, then you will be getting 10 mole of CO2, right? And again, same, 1 mole give you 2 mole. So 10 mole will give you 20 mole of H2O. Very simple. Actually, the stoichiometry part is very, very easy. When we will study from the starting, you will see there is questions which is very not difficult. They will only play with the language, not more than that. This is the only concept. Now see, I'm gonna solve this. And first of all, there is no reaction given in the question, so you need to write the reaction. And I think you are, just wait a minute. And I think you are aware of Haber's process, right? Since you just crossed class 12, you know Haber's process. In P block element, if you remember, you have studied Haber's process. Furqan. Okay, no problem. No problem. So see, number of moles of hydrogen molecule required to produce 20 moles of ammonia through Haber's process. Actually, Haber's process is to make ammonia, and ammonia has a formula, this NH3. How we make ammonia? So it's very simple. When nitrogen react with hydrogen, it will give you ammonia. Now you need to balance. You can see two hydrogen is there and only one hydrogen is there. So two nitrogen is there, and on the right hand side, only one nitrogen was there. So I multiplied it by this. Now the number of hydrogen on the right hand side is 6 and number of hydrogen on the left hand side is 2. So now this is a balanced chemical equation now. Yes or no? Now see, it's very simple, very simple. You can see 1 mole of N2 react with 3 mole of H2 to give 2 moles of NH3. One more important thing I want to tell you is that I asked you with respect to only CH4. They can ask you with respect to O2, CO2, and H2, anything. You know the relation from the balanced chemical equation. 1 mole give you 2 mole, 1 mole react into with 2 mole, give you 1 mole and 2 mole. You know the relation from how many moles you are getting, how much water. Okay. Now see. In the question, what is given? In the question, number of moles of hydrogen, that this is what we need to calculate. There is nothing like nitrogen that is mentioned in the question. Okay, so we don't need to think about this. Okay, but for the reaction we require, okay, to make a balanced equation. Now see, to produce 20 moles of NH3, that means you got 20 moles of NH3. You need to tell me how many moles of H2 is required. So from this balanced chemical equation, you can see you got a relation between those two. Very good. See how easy it is. So you are going to think it like this: 2 moles of NH3. Just think about 2 moles NH3. That is giving you 3 moles H2. So for 1 mole NH3, you will be getting 3 mole of H2. And again, for 20 moles, what you need to do? 3 by 2 into 20, and you will eventually get 30 moles of H2. So stoichiometry is not tough unless or until you are able to write the reaction. And you will be able to write every reaction with the completion of the chapters. Are you getting my point? Okay. So, Furqan, this is it for today. I'll see you in the next class, and we will start from very basic. This was only the trial class, so our